Hello everyone! In this project, we wanted to enhance learning effects and to train scientific reasoning of students by combining different learning methods. To do so, we tested the effects of a combination of out-of-school learning, in our case during a field trip, with traditional in-classroom instruction using a citizen science approach and tablets. First, let's address the question why this project is so important. Scientific reasoning is regarded as an important skill set which students are supposed to acquire during school. However, students show deficits concerning scientific reasoning when being tested. Therefore, scientific reasoning seems to require special training, which might not be provided by traditional in-classroom instruction. Another challenge at school concerns students' knowledge transfer into real-life situations outside the classroom. As learning inside the classroom differs from working outside the classroom in multiple ways, students cannot apply their knowledge to a real-life context. Therefore, the knowledge remains inert and is not used outside of school. To overcome this problem, it might be helpful to embed learning in an authentic context. An authentic context provides the possibility to bridge the gap between theoretical knowledge and practical actions. Thus, a combination of in-classroom instruction with out-of-school learning is reasonable, as out-of-school learning can serve as a small practical apprenticeship, during which the cognitive demands are the same as in real out-of-classroom situations. In our study, the teaching topic was ornithology, hence a field trip was conducted as an authentic activity. However, we wanted to go one step further and ensure that the students also transfer the knowledge acquired during the field trip back into the classroom. So we wanted to connect the different learning contexts to one another. To provide this connection, we embedded the teaching unit in a citizen science project. In a citizen science project, the expert status is transferred upon laypersons, meaning in our case the students, who work similar to professionals while collecting scientific data in the field. This, for one thing, serves as a very authentic activity for the students, as they can work like professional ornithologists and collect valuable scientific data in the field. And for another thing, the students take part in the citizen science project both out of school during the field trip and inside the classroom. Hence, parts of the learning environment stay the same and should enable knowledge transfer between the different contexts. Furthermore, the students were also given tablets to facilitate the knowledge transfer. As tablets provide a portable learning environment, as the students can easily take them with them wherever they go, seamless learning is supported. To assess the possible effects of the combination of out-of-school and in-classroom instruction using a citizen science approach, two different groups, an experimental group and a control group, were compared, which differed according to two dimensions. First, the experimental group participated actively in the citizen science project by going on the field trip and collecting data, whereas the control group did not take part in the project, did not go on a field trip, and merely worked with data of others inside the classroom. Second, the students either worked with their own data if they were part of the experimental group, or with national data if they were part of the control group, resulting in different levels of involvement for the students of the different groups. Our hypothesis states that the students of the experimental group show a greater increase in both scientific reasoning and factual knowledge compared to the students of the control group. Our method: the study followed a before-after control impact design, which means that the students filled in the pre-test before the start of the teaching unit, the post-test 1 right after the end of the teaching unit, and finally the post-test 2 6 to 8 weeks after the end of the unit. The sample consisted of 14 classes with 345 students in total. 155 students were girls and 163 students were boys. The average age was 11.21 years, as all classes were grade 5 or 6. The classes were divided equally among the groups so that each group was composed of 7 classes. The teaching unit consisted of 3 double periods in 3 consecutive weeks for each of the groups. For the students of the experimental group, the teaching unit was designed to resemble the working process of a professional scientist. In the first week, both groups received the same lesson. Inside the classroom, the students learned theoretical information about birds and their behavior. At the end of the lesson, students were asked to formulate their own hypotheses about the birds and which behavior one could most likely observe in the field. This lesson represents the literature research of a scientist, during which he or she collects as many information as needed to end up with a hypothesis which is supposed to be tested. In the second lesson, the experimental group went on a field trip where the students had the opportunity to check their own hypothesis while they were collecting data for the citizen science project using the tablets. The control group received another lesson inside the classroom, during which the students could check their own hypothesis using short film sequences. This lesson represents the process of data collection of a professional scientist, especially for the students of the experimental group who took part in the citizen science project. Finally, as a professional scientist would analyze his or her collected data afterwards, the students did the same in the third lesson inside the classroom. Students of the experimental group used their own data, which were collected during the field trip, and compared them to other data of the citizen science project, whereas students of the control group only worked with national data of the citizen science project, as they did not have any own data. So our results. We calculated mixed linear models with repeated measures. And regarding factual knowledge, the model only showed a significant main effect for time, but neither significant main effects for group, gender, or class, nor a significant interaction effect for time and group. This shows that both of the groups increased their factual knowledge during the teaching unit, but there were no differences in the amount of gained knowledge between the groups. Concerning scientific reasoning, there were no significant main effects for group, gender, or class either. However, once again, the model showed a significant main effect for time, showing that both groups improved in scientific reasoning during the teaching unit, and we also had a significant interaction effect for time and group, showing that the students of the experimental group improved their scientific reasoning in a greater way than the students of the control group during the teaching unit. You can also see this effect in the graph on the right side, where the experimental group is depicted in the green line and the control group in the orange line. So to sum everything up, our results show that a citizen science approach which combines different learning contexts is suitable to train scientific reasoning, as the students have the opportunity to work like professional scientists and thus improve their scientific reasoning. Hence, a citizen science approach should be implemented more often at schools to achieve the major goal of having the students acquire scientific reasoning skills. However, both approaches are equally well suited to convey factual knowledge. The benefits of a citizen science approach might be more apparent when factual knowledge would be tested with a practical knowledge test outside the classroom, which also assesses knowledge transfer, as this is the major problem when learning only takes place inside the classroom with no connection to real out-of-school situations. A practical test like that might be more likely to reveal possible differences between the groups. If you have any more questions concerning our study, please feel free to contact us anytime. We will be happy to answer your questions.